Okay, so today we are going to start with the concept of the energy. And in the concept of energy, okay, no issue. So basically, in the concept of energy, we have to discuss first the energy flow diagram. And for the energy flow diagram, we have to conserve the concept of energy. And the concept of conservation of energy is very basic, very simple. You already studied that concept in the sciences, that energy cannot be created or destroyed, can only be transferred from one energy or one form of energy to another, right? So energy cannot be created or destroyed. And in this topic, we have to discuss about the concept that how reactors, uh, we use reactors in our daily life in the industrial process to generate electricity, because that ray or that flow diagram is included in your syllabus, and they will ask with the reference of those process in exam also. We know there are multiple process, there are multiple options to generate electricity, but the electricity that is generated by the nuclear reactor, so that concept is included in your syllabus specifically, and you need to know about the whole process and the components we used in that process. So it can only be transferred. So again, this is the basic law of conservation of energy that you already know about it. Let's suppose if we consider any type of concept, let's suppose if we take the example of the fuel. So when we are using fuel in our daily life in car or different vehicles, so basically fuel give us the form of chemical energy, right? If we take multiple examples of daily life, just like the fuel, so by mean of fuels, we are taking the energy in form of chemical. And why we are using fuel? We are using fuel just to make our vehicles in motion. So basically, our main purpose of using fuel is to convert chemical energy into mechanical energy, right? So mechanical energy means energy due to the motion of a body. In simple words, kinetic energy we are talking about. And one more thing that we already know, that nothing is 100% efficient. No process, no uh, any type of machine or any type of generator is 100% efficient. It means that if we are going to convert chemical energy into mechanical energy, so not 100% of chemical energy converts into the mechanical energy. Some percentage or some ratio of chemical energy also converts into
Like 10%?
uh,
That's not percent of it.
okay, basically the percentage we are not going to discuss about that concept, that how much percent, because that is not included. We are just only talking about the concept. because chemical energy, because when we are burning the fuel to make the mechanical energy, so some of energy automatically converts into the thermal or heat energy, right? So you can see that in the process of fuel, you can easily apply law of conservation of energy, because our main purpose is to convert chemical energy into mechanical. But we know nothing is 100% efficient in the mechanism, in the machines, in the process of conversion of energy. So few percentage or few weightage of the chemical energy converts into the thermal. Same goes with all type of energy. Just like if we want to light up the bulb, so we are actually converting electrical energy into the light energy. Again, that bulb got heat up, it means some sort of or some part of the energy actually converts into the thermal energy also. Clear? Any confusion?
No,
Okay.
no, sir.
So basically, we are not going to discuss each and every type of conservation of energy for right now. First, we start to discuss the energy flow diagram that is included in your syllabus. Then we will discuss different resources, that how we convert energy from one source to another. But before that, we have to discuss energy flow. And in energy flow diagram, basically we have to discuss the concept of the nuclear reactor, that how we use nuclear reactor to generate electricity, right? So let's suppose first of all, if we consider the nuclear reactor, okay, the concept of nuclear reactor is also included in the section of nuclear physics. So we will also discuss that nuclear process in very much detail. That's why they also include that concept in this chapter, because that is already included in nuclear physics. So let's suppose initially we are having a nuclear reactor, and if anybody of you knows about the nuclear reactor, so basically in nuclear reactor there are some control rods. But for the time being, we are just taking the journal concept, not very deep advanced concept right now. So basically, initially we are having a nuclear reactor, and from that nuclear reactor, we are having two different paths like this. The first connection is passing through the pump. And if we start writing the name of the components in the diagram, so the first one is nuclear reactor, and this is the pump. We will also discuss that what is the working of that pump. Before that, we just connect another connection. So basically there are two connections coming out from the nuclear reactor. First one is passing through the pump. And what is the process of the pump? Initially, reaction starts and it will starts flowing from left to right, like in this direction. And after moving towards the right hand side, it will pass into the steam generator. The nuclear reactor, we know that the process of the atom bomb, or the name of the atom bomb, we already heard about it. And we also know that there are a lot of amount of thermal energy generates in the process of nuclear reactor, right? So that's why we first generate a lot of amount of heat energy. So that's why we first use a steam generator. Just like the example of the dam, what actually happens in the dam, that there is a turbine like a wheel or the propeller, just like the fans behind the boat, behind the ship. So same thing, that is known as the turbine in the process of energy generation. So we use water to make steam, and that steam will flow in one direction, and that apply force on that fans or that propellers or that turbines, that force that turbines to move in one direction. And when this starts to move, so that will generate mechanical energy, right? And if you know about the process of windmill, right? So what actually windmill do, when air starts to strike that windmill, so when windmill or the fan or the blade of the windmill starts to rotate, it will convert that mechanical energy into the electrical energy, right? Clear? Any confusion?
No, sir.
So basically, we are using the same concept. We are using steam to make that turbine run. And when that turbine starts to rotate, so it will generate mechanical energy. And with the help of that mechanical energy, we convert that mechanical energy into the electrical energy, right? Basically, we don't need to write a very detailed process for the time being, right? Because that is included in the electricity chapter and nuclear physics chapter individually. For the time being, we only need to know about the type of energy, right? That how much or how energy is going to be transferred from one process to another.
Like
I will write that.
also the types and also the
Yes,
types of energy.
yes. For
Okay, so like mechanical, chemical,
yes.
kinetic. Okay.
So that's are the concept that you need to write. So first we just complete our diagram, then we will write in the detail in the bottom of the diagram that what actually going on in this process. So basically just passing from the steam generator, it will move into the turbine. We will also discuss how so let's suppose if we are having a turbine over here. Basically in turbine we are just having a propeller or type of fan, we can say that. And if we talk about the energy flow, so steam is going to be generated into the steam generator, and that will move through that pipe. And you can see when it enters into the turbine, so it will start rotating that turbine in downward direction. So it will start to rotate in this direction. And we know that we have to just make this flow of energy continuous way. So we have to connect an other tube to the pump also, right? Because the wasted energy or the energy that is not completely converted into the mechanical will again move through the pump, and then we are able to reuse that energy. Okay.
Okay, sir.
Okay.
So basically we have to connect another pipe to complete this process like this. Achieve. So basically, the rest of the energy that we are not using to move the turbine, that will again move through that pump into the steam generator, right? And from steam generator, it will again move through that pipe backward into the pump that is connected with the nuclear reactor, right? Any confusion?
No, sir.
And finally, we are having the last main component in our process, and that component is known as generator, right? And the process of when we just use the turbine to make the mechanical energy. So by using that mechanical energy, we convert that mechanical energy into electrical energy, right? And finally, from this generator, electricity will supply to the national grid. It means the main towers from which electricity is going to divide into the towns, into the small cities, or into the small sections, right? So that is the final path. So it will move through the national grid, or we can say that the small towers. So basically, the process is very much simple. Now we just write the name of the energy that actually we are using in all the sources, all the processes that are connected in our energy flow diagram, right? So the first one is the reactor. Then we are having steam generator. Then we are having turbine. So basically, first of all, we use nuclear reactor that converts energy through the steam generator. And after moving through the steam generator, it will move towards the turbine. And from the turbine, it will move to the generator. And finally, from generator, it will move to the national grid, right? Now just write the name of the energy that actually converts from the first to the last part. So in the first part, we are using nuclear reactor, and in nuclear reactor, there is a source of energy in the form of uranium, right? And why we are using nuclear reactor? Because we already discussed that in nuclear reaction, we use to generate heat energy and energy in the form of radiation, right? So this will provide you heat and radiation. So this is the important part, that you need to know about the type of energy, that in which type of energy we are actually converting, or in which the process is going on. So the first process is we use uranium that will generate heat and radiation. And after moving from heat radiation, so we use some water to make a steam, because there is a steam generator. So definitely there will be some water to convert into the steam. So there are, in a steam generator, there is a concept of thermal store of water. And again, we know that nothing is 100% efficient. So some of thermal energy will add up into your surroundings, right? So thermal store of water plus thermal store or thermal energy also transfer into your surrounding. Clear? Any confusion? And in a steam generator, when this steam generators move forward, so what is the main purpose of a steam? To just move that turbine, and moving that turbine means we are using mechanical energy, right? So we are talking about mechanical energy, right? Plus there is also some sort of energy in the form of heat. Again, nothing is 100% efficient, so always there is a concept of heat involved everywhere. Then when we move through the turbine, so there is kinetic store of turbine. Because in turbine we are totally working with the process of motion, that is kinetic energy. Again, thermal energy in the surrounding. And finally, your kinetic energy converts into the electrical energy, right? So this is a simple energy flow diagram that is included in your energy chapter. And finally, that electrical energy supplies to the various stores or to different type of customers, right? That is mentioned with the name of national grid. So this is the whole process of energy transfer or energy flow diagram. Any confusion?
No, sir.
No, sir. Sir, I do have one question.
Yes.
Do we need to memorize like the entire process?
Basically, if you are not
Because in my book, it's very limited.
basically the writing part that we discussed in the last, that is the store of uranium. So that part is important. This section is important, like
It's not mentioned in the book. I don't know why.
store of uranium, or because store of uranium, the name uranium is important because that is included in nuclear physics. So if you don't remember that name in this chapter, so definitely you need to study that topic in detail in nuclear physics also. So that's why this process or the name of energy or the type of energy or the conversion of energy from one to another is very much important. Otherwise diagram, the whole diagram, you they never ask to draw all the diagram. Sometimes they ask you to write the name of the components that is missing in the diagram. Okay.
Okay.